We'll take 2 videos of you guys, and I'll put you on TV.
That's cool.
Yes,
That is
yes.
cool.
Definitely want to make sure you guys get on TV, and so you can see it next week. But I'll have that information after the presentation, and I'll take questions afterwards.
It's not a question.
Oh, yeah. Comment?
You know those people surrounding the bars on the Today News? I was on TV there before.
Oh, you
yeah.
were? Very cool.
We were on the
You were on
show.
TV before?
Yeah, we were on, and we also have a video of us on YouTube
Oh my goodness.
eating like a fruit juice.
So you guys are way advanced. All right, let's get right into the presentation, shall we?
Eating Greek.
Oh, you know what? We'll share comments after. Sound good? Sound good? Because I have a lot to share with you guys. I want to make sure I get through it all. So my name is Pamela Gardner. I work for WBZ TV, Channel 4 in Boston. Some background about me first. I'm not from here. I'm from Indiana. Anyone know where Indiana is?
About in the middle of the state or on the side.
In the middle of the country.
Yeah.
Right in the middle of the country. So we don't have an ocean. We don't have mountains. It's pretty flat. It's actually in the middle of severe weather country, kind of close to Tornado Alley. So I grew up with a lot of tornadoes, a lot of severe weather. We have all 4 seasons in Indiana. So coming to Massachusetts, it's very similar. I'm used to the spring, the allergies that come with spring. If I cough, that's why. Allergies are a little bad. Winter, I'm used to snow. Not this much though. Do you guys know you lived through a historic winter? Record. The most snow of all
Last time we had
time.
2 feet of snow.
It was crazy, right? I lost him. So for the rest of your life, you can say you lived through a historic winter, record-breaking. You can brag about it forever.
No, we broke the record. I broke the record.
Okay.
I forget where, but they got
Several. So, continuing on, I'm used to the snow, but coming here is very different. Very, very different dynamics go on here, and it's very interesting because in this location you have the ocean-enhanced snowfall. You have the mountains that give you orographic lift that can produce more storms sometimes. But coming here, it was very, very interesting. So I wanted to move from Indiana to somewhere different. It's been wonderful living in New England. We've been exploring and going to different cities, but in my day-to-day job, my job is to forecast what the weather's going to be. Why is it going to be sunny? Why is it going to rain? Could we get severe weather? Like yesterday, we had a random severe thunderstorm warning. I don't know if you guys noticed, but there was a storm that moved through the South Shore, and it produced some 3/4 of an inch size hail, which is just a bit smaller than a quarter. And we had damaging wind gusts that moved through. No damage reported. But why did we get one severe thunderstorm and the rest of the storms weren't severe? So that's something we do on a day-to-day basis as meteorologists. In Indiana, grew up there, born and raised, lived there almost my entire life. So moved out here. Went to Ball State University, which is where David Letterman attended. That's also the Papa John's pizza guy. That's where he attended school, so maybe you know about him on the commercials, Papa John's. I graduated in 4 years, thank goodness. Sometimes that's not the case, but I graduated in 4 years from Ball State University. My major is in telecommunications, emphasis in news. So I learned how to write as a news writer because it's different versus writing an essay. News writing is a bit different. Learned how to be a photographer, producer, director. I did sports once. That was interesting.
I only watched the news commercials.
News anchor. I learned how to be an anchor, learned how to be a meteorologist. So, as soon as I was able to learn all of these different things, I knew that weather was what I wanted to do. Chose to minor in meteorology, and then thankfully I got my first job. And then when I went out to Terre Haute to be the weekend meteorologist there, I took another 2 years in school at Mississippi State University online. So 6 years. Took 6 years to become an official meteorologist. I chose to do TV meteorology, but I could have worked for the Navy. I could have worked for the National Weather Service. I could have worked in many different places. but chose to do TV. It's fun. Good stuff. So weather. Whoops. Ooh, going too fast here. So weather. We love weather. It's very interesting. It can change on a dime, as you know, here in New England. We can have a day with snow and then all of a sudden get to 70 degrees. A day like today, it's cool. It's not as humid. We had to change that move through, where the other day it was mid-80s and kind of muggy. Now we had cold front move through, swept everything dry, and it's a beautiful day. So here's the weather team. These are the folks we work with, but this is the group you see on TV for the WVZ weather team. That's me, yeah. So you can catch me on air Saturday and Sunday mornings between 5 a.m. and 10 a.m. That means I wake up at 2 a.m. in the morning. Friday nights, I'm not out with my friends. I go to bed at 7 p.m. So it's not a glamorous, necessarily, it's not a glamorous life, but it's something that we love to do, and it is what it is. Schedules are crazy in TV. You gotta know that. Eric Fisher, you can catch him on air Monday through Friday. He works a 3 p.m. to 11:30 p.m. shift. So you would see him on TV 5 p.m., 6 p.m., 10 and 11 p.m. He came from the Weather Channel. Yes, that's where I knew him from. And then he contacted me about coming out to Boston, and I said, sounds great, let's do it. Let's make the arrangements. And so that's how things got started, and I moved here this summer. Danielle Niles, she works morning weekdays, so you would see her before school as you're getting ready. And Barry is on the weekend evenings. There is always a meteorologist on duty, 24 hours a day, 7 days a week, even holidays, because the weather doesn't stop, the news doesn't stop. Someone has to always be watching, especially in an area like this where you can get storms during the summertime, the springtime. So moved to Terre Haute, Indiana, moved back to Indianapolis, Indiana, and that's where I just came from. I worked at the CBS affiliate in Indy for 3 years, moved out here, yada, yada, yada. So, let's get into weather. Some of the science, which I know you guys have learned some of the background about, what causes weather, and then we'll get into how to come up with the forecasts. We're going to build off these things. What causes the weather? You have the few main weather controls right here, the sun, the atmosphere, and the water. All those work together to produce the water cycle. Have you guys heard of this concept?
We learned to dance and we studied.
Very good, very good. You know what? We all of us meteorologists have to study the water cycle. We have to know the basic science, the physics, the math that goes behind the weather in order to actually be able to predict it. Because it is very complicated. Very, very complicated. We have condensation, evaporation, lots of big words going on here in the water cycle. Precipitation. My job is to figure out, is it going to be precipitation in the form of snow, or ice, or rain, or sleet, hail? Exactly. So we have air masses also that help to fuel some of our systems here. We have continental polar air right over Canada. It generally stays right over Canada. Normally colder air there. Continental Arctic air over the North Pole, that normally sits over the North Pole, but sometimes it creeps into New England. And when it does, that's when we can have huge cold snaps, a storm, maybe a blizzard in between that air mass moving in, and then all of a sudden temperatures dip to 0 for the high temperature. So that's a significant one that we would like to watch. Now that continental Arctic air, that's not going to bother us for a few months here. But continental polar air, as that moves in, that could give us a completely different air mass where it's colder than what we've had the last several days, 20-degree temperature drop, maybe 30, depending on how strong it is. We have maritime tropical air, warm, moist air. If you guys have been to Florida, Texas, around the southeastern coast, you know it's hot, it's humid, and in Disney World, that's where maritime tropical air generally is, where you'll have a bright sunny start to the day. It's hot, it's muggy, it's humid, your hair is all frizzy, and all of a sudden in the heat of the day, a pop-up thunderstorm. That's a maritime tropical air mass. Well, when that moves our way, that can help to give us severe weather. Or continental polar could also help to give us significant changes. So we have the air masses that work together, right? And then we have the atmosphere, the general atmosphere. You have high and low, high pressure, low pressure. Differences in temperature, differences in air masses create differences in pressure. The pressure change creates the wind. So in the middle of this map here, which, don't get too caught up on trying to interpret every little thing on these maps. I just want to show you examples of what we would use. This is something you would go to school for, to learn how to interpret these weather maps really, really well. But in the center of the country, you see the big H, and right over New England, you see a big L. That means low pressure over us. High pressure over the middle of the country. So airflow, there it is, the general rule of meteorology right there. One of many, but air flows from high pressure to low pressure. Bigger the difference, the stronger the winds. So in this example, there's a high pressure ridge right over the center of the country, low pressure right over New England, but notice all these bars very close together. That tells what the pressure level is, but those bars are very close, and there are lots of them in between the high and the low. That means it would be very windy. We have the fronts in between the air masses. Cold front, warm front, stationary front, occluded front. Generally what we'll use normally on TV if we draw them in. Sometimes we don't, but cold front, warm front. Those are the main ones that normally you'll see. Stationary front though, sometimes you'll get a front that stalls out right over us. To the north of it is cold air. To the south of it, warm air. And along that stationary boundary, you could have little thunderstorms that move through, little areas of low pressure. Occluded front, that occurs when cold air overruns the warm air very, very quickly. Pretty mature front there. But cold front, that's where you could see thunderstorm activity. Warm front, maybe a few showers, maybe an isolated thunderstorm, but it doesn't happen too often. But warmer air, after that front passes through, you get warmer air. Cold front passes through, colder, drier air. We also look at the clouds. I want to look outside, see what the clouds look like, because that can tell you what kind of air mass is in place or what's yet to come. If you notice outside, we have cumulus clouds, but it's very, very dry out there, and the clouds aren't really towering. They don't have a lot of build up top, so we know there isn't a lot of instability or lift in the sky, and we know that we're not going to get any thunderstorm activity. Now, cirrus clouds, if you see those feathery, light, beautiful clouds on a fair weather day, they're pretty. They look like feathers in the sky. Cirrus means fair weather in place, probably not going to get much activity in the immediate future. Of course, as we know in New England, weather can change dramatically within several hours, so you also have to know what's coming up later on. Cumulus clouds, so if we have those puffy clouds and they're really starting to tower high in the sky, that could mean a thunderstorm's developing or a rain shower. Worst case scenario, you get a cumulonimbus that towers really, really, really high, higher than most of the planes fly sometimes, but they're huge. They look like anvils from a long distance. And those can produce the lightning, the hail, sometimes, tornado. Stratus clouds, those are low-lying clouds, but they're flat, primarily flat. Fog. Fog is a stratus cloud. Sometimes it takes a long time to get those stratus clouds or the fog layer out on a normal day. But yeah, so bright colors on a radar, that means bad weather.
Yeah.
Storms. Severe storms.
Usually green.
Where do they occur? Severe storms. Average number of tornadoes per year. I want to show you this. We have Tornado Alley right in the middle of the country. Kansas, Oklahoma, Texas. But there's also a little bit of a secondary tornado alley there. That includes Indiana, where I was born, Illinois. So I used to be terrified of storms. Growing up in Indiana, we would have tornadoes all the time. Anyone scared of storms? Nervous? You kind of get surprised when you hear a loud crash of thunder and it wakes you up in the middle of the night.
I only like thunder when I'm awake.
Yeah. So
So
storms can be a pretty scary thing if you don't know what's going on inside them. Hopefully after today you'll understand what goes on inside them, because I'll show you more info about it. But okay, we have Tornado Alley here. Dixie Alley, that's another kind of secondary tornado alley that in this location we're getting more and more tornadoes that pop up per year. Very, very dangerous to storm chase anywhere, but especially in Dixie Alley, where there's a lot of hills, there are a lot of trees, and generally a lot of those tornadoes, by the time these systems move into Dixie Alley right there, it's nighttime. So you get a higher number of injuries and deaths that occur because it is overnight where those storm systems occur. Florida also has a high number of tornadoes per year, but they're generally waterspouts. They occur over the ocean.
Yeah.
So if
Is it really?
one thing occurs right here, well, that's going to be counted towards the average for Florida. But they don't, in these areas, we don't normally get the big, long-lived track tornadoes that are very dangerous. It's normally here. There are certain ingredients that make this area prone versus others. You see the rest of the country here, nothing. On average, California may not see any tornadoes per year. And that's New England.
Yeah.
They could see 1 or 2 per year. And that's if a powerful front, moves through, sometimes a very small spin-up tornado. Normally we would not get a long track tornado. Another comparison, I know this is kind of tough to see. All I want you to get out of it, this is the middle of the country, and that's where we have tracks of tornadoes. Oh yeah, that's better, thank you.
1956 to 2014.
So, severe weather ingredients. What do we need for a severe storm or a tornado? The spin in the atmosphere to get a small tornado to move in. Severe weather, you have the cold Arctic air, you have the continental polar air too moving in, you have the Gulf moisture, maritime tropical air mass. Remember I showed you that map earlier? Those two air masses collide and sometimes you get little mini spin-ups in those systems and you could get something like that.
Tornadoes in the oceans are really, really cool to see.
Yeah, yeah. Just as dangerous though if they move on land. But there's another example, this tornado right there. That's a pretty
A
picture.
rainbow and a tornado.
Pretty picture, but dangerous.
And
Yeah.
a tornado?
Yeah.
Cool.
Let's see. Whoa, nope.
Oh.
Okay, well I had a video. It's not gonna work, no big deal. Just wanted to show you tornadoes spinning up, but let's see. Come on.
I know how hurricanes stop.
Okay.
They run on a
So we'll move on here. If a tornado or a severe storm is heading our way, the National Weather Service, they're the ones responsible to issue a watch or a warning if that storm is very, very bad. So this is an example, I couldn't find one from New England, but this is in Alabama, just general information. What I want you to get out of it, tornado warning versus a severe thunderstorm warning versus a tornado watch versus a severe thunderstorm watch. We have different things going on. But watch versus warning, that's what we want you to get out of this. A watch would be issued for a large area, many different counties, and a watch means watch out. Conditions are favorable for severe weather to happen, but it may not happen. But you still want to pay attention if you're outside. A warning is going to be in a smaller location, part of a county normally, and this is issued within 20 minutes, 30 minutes of the severe weather occurring in the location, or it's already happening. So a tornado warning, severe thunderstorm warning, means we're warning you, you need to get to a safe location. You need to come inside if you're playing outside because the storm is going to get really bad, or there's a tornado in the atmosphere that we see in the radar. So warning versus watch. Watch means watch out, warning means it's happening now. And if a tornado occurs, we don't know how strong it is necessarily. There's no ranking when it occurs because the National Weather Service has to go out and survey the damage afterwards. And there are 2 different scales. One is gone. There's a new one that has replaced it. The F scale, the Ted Fujita scale. Fujita scale. So so the Fujita scale is the old scale we used to rank tornadoes. And the EF scale, the enhanced Fujita scale, has replaced it. It replaced the F scale in 2007, to be exact, and it aligns wind speeds more closely with associated storm damage. It also takes into account construction quality, because the old scale didn't necessarily pay attention to that. There's a big difference if a tornado smashes through a mobile home versus a big skyscraper. There are whole different ways of how those buildings are constructed. So the National Weather Service goes out and surveys the damage, and then they give it a scale. They say, yes, there was an EF1 tornado that moved through yesterday. It normally takes them a day to get out there to survey the damage. EF1 Well, it goes EF0 to EF5. 0, 65 to 85 mile per hour winds. And then it goes up to EF5, over 200 mile per hour winds. That's incredible. But as you get farther down the scale here, then it's not as likely to see it. That makes sense. So EF0, EF1, those are the ones that will kick up your annual tornado average. But EF5's rare. Maybe a few of those would occur per year, and that would normally happen in Plain States, Tornado Alley, Oklahoma, Kansas.
That W is so strong.
And here's an example of the EF0 damage, EF1, 2, 3, 4, 5. And by 5, you get to catastrophic. Any building that was there, gone, wiped off. But again, those are rare. What we've had in this area, yep. Oh. Oh, okay. Oh, sure. No, yeah. So, okay, questions about what we've gone through so far? Yeah.
Once when my mom was baking brownies, the oven turned off.
Whoa, that's crazy. Okay, questions about what we've gone through. Questions.
Not comments, questions.
Do you have a question? Okay, comments we'll take after. Sound good? All right, question?
How will like EF2, EF3,
Mhm.
EF and EF4?
Yeah, so in our area here, we've had EF0, EF1, EF2, those have occurred. Revere had a tornado that moved through last year, and it was ranked in EF2, which is really rare. That doesn't happen very often, and that was a pretty strong tornado. It had 111 to 135 mile per hour winds. So it did some significant damage in that area. Now, once you get down to EF3, 4, these are pretty rare. EF5 almost never happens. You have to get something really powerful to get that. But these are more likely if a brief spin-up tornado occurs.
How do tornadoes start?
How do tornadoes start?
With really strong winds.
Well, you have a thunderstorm that develops. First, here's the key. Tornado has to develop off of the thunderstorm. So we have something called a mesoscale spin-up, something that happens inside the storm. And if you get enough spin, sometimes you get enough lift as well, because we have to have some sort of mechanism underneath the storm, the inflow of the storm, to help turn. We call it wind shear too. So you get a storm that develops, you have an updraft, downdraft, and on the backside of the storm you get a wall cloud. Wall cloud to funnel cloud, which doesn't necessarily touch the ground. Once you get a tornado, it's touching the ground. So you get that spin. And it's like an ice skater too. The tornado, if an ice skater moves their hands really close to them, they'll spin really, really fast and they'll be really small. But if they go out like this, then the tornado would be bigger and it would appear that it wasn't spinning as fast, but it is in the
Are they
extreme
usually
center, so.
smaller or bigger?
Normally the tornadoes are small, but a lot of what you see on TV they're going to put on the bigger tornadoes because they look more impressive. But most of the time they're going to be small tornadoes that spin up in a very, very small area, affecting only a few people. Okay. All right. Yep.
What is hail?
Hail. That is kind of a ball of ice, but what you have in a thunderstorm, you have updrafts and downdrafts, okay? You have a piece of ice in the storm. So this piece of ice goes up in the updraft. The stronger the storm, the more updrafts and downdrafts you have. So if the piece of ice goes up once and then falls to the ground because it's heavy enough and it can't get picked back up, you may have a small, tiny pea-sized hailstone. So it's ice. But if you have a big hailstone, like sometimes you've seen tennis ball size hail, baseball, golf ball, those are huge hailstones, and you have to have a very powerful storm to take that little pea-sized hail, take it up in the updraft again, then it falls back, gathers more moisture as it falls, and then goes back up again, and then it gets bigger, and then it gets bigger, and then finally the updraft is not enough to hold it up in the storm and it falls as a big hailstone. But that's very rare too. So, okay, yeah.
Why do tornadoes always go in hot areas, not mostly cold areas?
Tornadoes need moisture to collide with the continental polar, continental or maritime tropical air mass. So you need these two air masses to help spin. And the tornadoes generally will occur on a nice hot day, not like today, but on a hot day with humidity and moisture, because once the air gets heated up, you have, let's see, lots of stuff bubbling. I wish I had one of my props with me, but, so daytime heating has to occur, right, to get a thunderstorm to bubble up. So it's kind of like you're cooking, you're boiling water, and you notice the bubbles rise, and the heat is going up, and then you get all this stuff colliding with thunderstorms developing high in the sky, and then the tornado can occur. It's very rare, but you have to have a twist to it in there as well. So something we look for in our weather maps are different lapse rates, different things going on in the atmosphere to indicate that there's twisting going on high in the sky. Yeah. But on a hot day where you get a lot of daytime heating, that's the best bet to see something like that. But it doesn't happen too often here, mainly in the Plain States. So, okay, you think that's enough?
Yeah, I mean, yeah,
Okay.
you're the, yeah, I saw them
Oh,
bursting
okay.
with questions.
Gotcha. All right. So we're going to move on. I'll take more questions a little bit later. Let's see. Lightning. Okay, off the tornadoes, because that doesn't happen very often. Lightning, this is something that can occur with every thunderstorm. It doesn't have to be severe, but it can occur out there. Lightning, very, very dangerous, especially when you're playing outside.
There is
And
something
here-
called ball lightning.
Yes, here's an example of why you don't stand under a tree during a lightning storm. And thankfully I was not standing under a tree during this lightning storm. So this is TV magic here. It's not what it seems to be. I'm not close to that tree whatsoever, because as we were setting up that day for a live shot, we knew not to stand there. Lightning is attracted to anything tall, and I'll explain more in just a second. But the photographer and I had to go and report on a severe storm moving through. We were at a truck stop in Illinois.
Wow.
So no tornado or anything, but it had a lot of hail, heavy rain, and lightning moving in. So they wanted me to go on live TV and talk about it. Okay, yes, so I'm standing out there, it's raining. The photographer's in the car, he's on a laptop, because we didn't want a live van that had a big mast up top and a little mini microwave dish. That would attract lightning. It's metal and it's tall. We did not have one of those. So we were, again, also covered. Used the laptop to get the video on TV, and I was using a cell phone to get my audio onto TV. The anchors were talking to me. I said, yep, the storm is approaching. You can see the rain wall right behind me. And then all of a sudden I hear crash, crackle, and I see everything light up next to me. And I said, okay, it surprised me a lot. So this is live TV. And I'm like, oh, okay, I gotta pack my stuff up because things are getting pretty dangerous out here, as you probably heard. Lots of thunder. So we'll get back to the station. And when we got back, the photographers there said, you won't believe what happened. You gotta look at your video. So they cut it for me, and then I saved the still image. And I was like, geez, that is too close for comfort. That is nuts. So it does get dangerous out there. And we make sure safety is #1 for our crews and staff. That's why we were at a truck stop and not in that field or anything like that. So how does it form? How do we get lightning to form? We have negative charges in the lower part of the cloud, positive charges on the ground, and opposites attract. So that charge wants to get to the ground from the cloud as best as it can, as quick as it can, as quickly as it can. So it'll find anything tall, metal as well, telephone poles, trees, let's see, golf clubs. If you're standing in the middle of a field with a golf club like this, that would attract lightning. That would attract lightning. And people who get struck by lightning, the lightning bolt is using that person as a way to travel through the ground. So it's getting to the ground. It doesn't want to strike a person, but it wants to get to the ground. So that's why lightning can be very dangerous. You never know when it's going to strike, where it's going to strike. We can't necessarily predict where a lightning bolt is going to strike. Though And this is how science, this is how studying meteorology continues forever, because it's always changing. And we're not that good yet, hopefully we will be, to predict exactly where lightning may strike. But we can at least see, if we see a thunderstorm developing, we can say there's probably lightning with it, and it may occur ahead of the storm or anywhere, around the storm. Now, sound travels slower than light, and that's why there's a delay in between things. If you hear thunder, that means lightning already occurred. And when you hear thunder, or first, I'm getting ahead. You see the flash lightning, right? Count the seconds until you hear the thunder that follows. That flash goes with the thunder. It's together. And take the number of seconds, divide by 5, and that will tell you how far away the storm is in miles. Feel free to read that again, digest it, write it down. And you can try it from the safety of your own home. We don't want you to be outside. But if you hear thunder, time to go inside. Done playing, you want to be safe. So thunder occurs when you have a bolt of lightning. It's going to heat up the air. It takes space when you see a lightning bolt, right? So it heats up the air really, really, really fast. And because light travels faster than sound, you hear the thunder afterwards. So the thunder is the part that it's the result of that heated air right around that thunderbolt. So the air has to expand really fast and then go back to where it was. And when that occurs, that's where you hear the thunder. Hopefully that made sense. Okay, so moving on. Hurricanes. This is something that happens every once in a while around here. I'll take some questions and comments. Should I?
No, continue.
Continue, okay. Afterwards, I know. Hurricanes, these are huge things. This is why we love satellites, because we don't necessarily have all these stations across the ocean to figure out when a hurricane may develop. We use a lot of satellites to get that information. High in outer space, they orbit around the Earth, and the satellites spit back information to our computers that we use. And it'll plot it on this satellite picture, showing us the cloud, showing us the eye of the storm too. Hurricanes are very, very, the significance, what am I trying to say? The eye of the storm, that's what we look for to determine a hurricane versus a tropical storm versus just a regular nor'easter moving this way. Different things classify it as a hurricane. But hurricanes can last over a week. They have strong winds too, 75 to 200 miles per hour. We could also see a tropical depression, tropical storm, and then you get category 1, 2, 3, etc. This is just a look at all the different tracks a hurricane has taken over the last several years, 50 years or so. The basic shape you notice is it moves off the coast of Africa and moves this way towards the US. So we look out here to see a tropical disturbance to figure out, are there a bunch of thunderstorms starting to gather together? And if there are, then we look closely at it. We make sure we monitor it. Then we also want to look at the temperature of the water, the ocean water. Notice this, most of the hurricanes follow the Gulf Stream, which goes in this direction. So it wants warm water and it wants calm conditions. Different from a thunderstorm, where thunderstorms need twisting, they need wind shear is what we call it, to get a good interaction with the clouds. But hurricanes don't want wind shear because it could be sheared off, it could be too violent in the atmosphere to get it going. Hurricanes need some prime conditions, so calm in the upper levels of the atmosphere and warm water. It's going to take the path of least resistance. The warmest water normally ends up being in the Gulf of Mexico, but you get very warm water here, southeastern US. The water off the coast there, I don't know if you guys heard Ana, Tropical Storm Ana. Maybe you heard it over the weekend, but that hit the coast. It did not become a hurricane, but it did strengthen to 60-mile-per-hour winds, which is pretty strong, just under Hurricane 1 status. But it took the path of warm water, and then all of a sudden it stopped once it hit land. The friction of the land will stop the hurricanes too. But the effects of it can still move inland. The difference between tornado scale, remember the EF scale? We know the EF scale after the tornado hits. We can come up with a scale for the hurricane or storm before it hits land. So we have way more warning when these storms develop. And we have more time to prepare, which is good. But Saffir-Simpson hurricane wind scale. So we have a tropical depression. The winds, not too impressive. This is a normal storm that would move through New England. You get strong wind gusts. Okay, tropical storm gets up to 39 to 73 mile per hour winds. Category 1 gets higher, 74 or higher, 96 mile per hour. Category 3, 4, 5, 157 miles per hour or greater. Category 5 is the strongest. But once you get to category 1, 2, 3, they also put in the pressure levels, and they also put in the storm surge levels. So if we have hurricane hunters that go through, they fly over the hurricane, the eye of it, and they take different measurements, and they say, we have looks like the storm's moving pretty slow. It's got winds of 84 knots. And you have to convert, because they use knots in reporting some of the weather information. Okay, that's about 96 miles per hour. That would be a category 2 with the wind speeds. And then the pressure is really low, 96.5, and then 6 to 8 foot storm surge approximately. Pretty high storm surge. It could create flooding along the coast. Then it would be category 3. National Weather Service, these are our great partners who work in Taunton, Massachusetts, not too far from here, Taunton. They're all in charge of issuing the official watches and warnings for severe weather. And they also issue a forecast discussion every day, which is very helpful, because sometimes it'll talk about big weather events, and we need to compare forecasts, which every meteorologist comes up with their own forecast for all their shifts. So we have our own numbers, our own theory of what's going to happen in the coming days. If you compare from station to station, you may notice that the numbers are different. And that's because each of us have a different opinion of what the weather's going to be. Maybe I have 85 degrees for the day, you change the channel, you see 84 degrees for the high temperature. But it's generally the same. It's going to be warm, that's all you need to know. The National Weather Service does their own forecasting as well. Sometimes the numbers match, sometimes the sky condition matches. Day like today, sky condition matches, partly cloudy, beautiful day, great temperatures. But if there's a blizzard, or if there's a severe weather outbreak moving in, which there isn't, we have great weather these next few days, but if there was, we would consult with other meteorologists within our team. The 4 of us, Eric, Barry, Danielle, and I, would all go through and we'd be calling each other and saying, okay, what do you see? And here's what I see. Okay, well, here's what I see. And we'll compare and make sure you guys have the most accurate forecast you can get for that huge event, because priority here, saving lives and saving property. So we want to make sure you're safe and well prepared. But the forecast discussion is something you guys can also take part in as well with the National Weather Service. If you are interested, I can send you guys the link and email all this information, because it's nothing we want to hide. We want you guys to be your own forecasters as well, if you want to. Doppler radar, that's our defense against all these crazy storms moving in. So I'm going to get into some of the technology. If you're confused about it, I'll take some questions after we get through this. But hopefully I explain it as basic as possible. We have Doppler radar. That is our biggest tool that we use to predict where severe storms or normal snowstorms are going to go. Doppler radar sends out a pulse of energy into the sky, bounces back to radar. So it throws out, like a baseball, throws it out far, and then it comes back to us, our computer. Whatever that object is that it hits out there, say it hits that lunchbox in the cubby hole right there. So Doppler radar, we throw that energy out and I get it back. And I interpret what it is, and I think, wow, that's a really big object, so that would be really bright on the map that I plot. Doppler radar, thankfully, automatically plots out all of these objects that it hits. The bigger the object, the brighter the colors. So this is telling us a lot of information. This is a system that moved through New England in 1998, a little bit ago, a few years ago, and this says to us that we have big objects right here, where we get the very bright and dark colors. Some small objects here, this would say light rain. Then you get some very heavy rain, some hail, potentially in this area as well. That's what we use Doppler radar for. But there are some other things we use it for too, which we don't use on TV. This is what you would see on TV. The normal colors with the storm. This is in rain mode. This is in, let's see here, velocity mode. That's what it's called, technical name there. And this shows twisting in the atmosphere. So us at the station, we're monitoring these things behind the scenes too. This is your traditional Doppler radar, but this is something that has just been added in the last couple of years. Dual pole radar, which tells us a whole lot of information. I'll explain in a second. But here's twisting. This is not a bow echo. Why am I? Do you know what? Hook echo. Oh my goodness. See how it's hooking? See how it's hooking? This rain is somehow wrapping around something as the storm moves through. Well, this on velocity mode will show us that there is something twisting. There could be a tornado that may develop out of this funnel cloud at least. But green going towards the radar, red going away, and with bright colors close together, that means there is twisting. So there would be a tornado warning issue. That's the red line you see. Okay, so down here we add dual pole in, and now we have all these other pictures that can really help explain what it is. This is indicating it's picking up debris, so it's already on the ground. There should be a tornado warning, definitely, and this shows wind speeds too. It is very strong, that example. Dual pole adds a whole other element. So we not only have this radar throwing a ball, catching it back, but we have a radar scanning it up and down too. And to get a cross section, now we can tell how big the hailstone is and warn you that your car is going to get pummeled with tennis ball size hail if you don't move it into a garage or somewhere covered. We can go on TV and say that because we have that information now. And how big the raindrop is. Is it going to lead to flooding rain? Or is it going to just be a mist falling from the sky? Dual pole is the most significant enhancement made to the nation's radar network since Doppler was first installed in the early 1990s. Cool technology. And we're still learning about this stuff too. All of us meteorologists from the National Weather Service, the Navy, all of us on TV have to take courses to come up to date with the latest technology because it's changing so much. So not only does our job entail physics, calculus, lots of it, it also includes lots of technology, and it includes a lot of graphics design too, which I'll show in a second. Old radar, new radar, cool. We get more info now. Good stuff. Moving on to nor'easters. How am I on time, by the way?
About 10 minutes.
10 minutes? Okay.
Yeah,
that's
they
okay.
They have a lot of questions.
Okay. And I want to make sure I take the video too.
Yes.
Yes. Okay, so nor'easters, they're pretty cool. Something that occurs around here. They can produce watches and warnings and all that stuff. Remember, watch versus warning. Watch means watch out. Warning means it's happening. Okay, so nor'easters produce severe coastal flooding, erosion, hurricane-force winds, blizzard conditions, very heavy rain sometimes. And that erosion is something that eats away at the beach, where it could look different, maybe. It's not quite as high as it normally could be, so it kind of digs out a section of the beach a little bit. This is an example of a nor'easter, what it would look like on satellite. Notice there is no eye. Sometimes people compare nor'easters and say it's like a hurricane, but it's completely different. It's not coming from warm tropical waters. It doesn't have an eye, and it doesn't have certain criteria for pressure. So we had snow. This is in 1978. Like that? Yes, so this is this year. And that was actually the first snowstorm that moved through, the first blizzard. So I should have updated the picture with total snow that moved in. Blizzard of 78 still stands as the worst ever that hit. Worst single storm. Ugh, glad we're out of that. Let's get through this. Blizzard, blah, blah, blah. One thing that blizzards, hurricanes, powerful storms that move off the coast can do, it produces some very, very strong winds that push up the water. And this is an example of Situate. After it pushed up the water, all that water froze. Oh, frozen seawater in Situate. So, making the forecast. Hopefully we can get through an example of some of our weather maps we have. From current conditions, from outside conditions, looking at the sky, we run computer model information to forecast what the weather is going to be in the days ahead. So when I get into work, I start off with current conditions. I write down what the temperatures are, what the wind speeds are. I also take into account climate. Is it summer? Is it winter time? If a forecast model is saying 32 degrees and snow in the middle of July, I'm not going to put that in my forecast because the models are guidance. And we have several different ones we look at each day. But when it comes down to it, we have to be smart enough to know that the model could be off. Computers, they can be off some days. So we forecast about 10 to 14 days in advance, but it doesn't get very accurate. Once you get 7 days out, 8 days out, it'll change from day to day with that forecast. Here's a look at one of the maps we use. This is a surface map. Notice in the center of the screen in 12 hours, 24 hours, 36, 48, 60. There's a line of storms that develops. That's what occurs. So I'll write it down. I put my forecast into my maps, and our computer's right there. This is our office. We have a lot of numbers, a lot of pictures that we look through, and we put everything into these weather maps. And this is one of our hour-by-hour futurecast models that we show on TV, and we use this to show you where the rain is going to be. So on this particular day, we have Foxborough located with the big Pat symbol right there to show you that you can't miss it. But this was coming up to the Patriots game in December that we had. And we wanted to show you that rain was headed towards that game. We plot all the numbers in here, sky condition, and then we present it in this area, or with Carrie on the anchor desk. Now the anchors do have, they have teleprompter, they have a script that they read off of. We do not. We just look at the camera and we actually see this view. We see the weather maps behind us. We have a chroma key, so if you wear green, yellow, or turquoise, you would actually get the weather map on you. We're not allowed to wear those colors. So St. Patrick's Day, normally we get pinched because we can't wear green. I try to wear a green bracelet or something. But there's Danielle, and she's presenting the forecast for noon, and we use those TVs on each side to know exactly where we're pointing. It's all magic, TV magic. So if you are interested in becoming a weather watcher, this is something new that we have. You can sign up with the permission of your parents or teachers too. Feel free. We always love to get weather reports from your home because we can't be at your house in all these different places. We have to forecast for millions of people, and we want to be as accurate as possible. So we do use your forecast and your report on TV, saying the temperature, if you're getting rain, weather app if you're out traveling, and now I'll take questions. Should I do video first?
Yeah,
Probably.
yeah, let's do
Okay.
the video first. Yeah.
And with the video, you can get some energy out.
Yes, absolutely.
I'll grab my purse back here.
I think I do. No, they're not.
Okay, so,
Should we go outside?